Hello dear students, good morning everyone. This is the third revision lecture for class 9th students, and in this lecture today we will discuss about few more remaining terms that is related to first chapter motion, and the terms that are very important for examination point of view and for your clear concept. And when you just listen about all the terms carefully, then your previous concept and forward concept will be clear. Just see the first term in today's lecture, that is uniform motion. Uniform motion. As I discussed earlier, motion means what? That is the position changing with respect to time and surrounding, and in which case the motion is said to be uniform. There is two concepts. You can use any one. Whenever the body covers equal distances in equal interval of time. Listen again. Whenever the body covers equal distances in equal interval of time, then the motion of the body is said to be what? Uniform motion. Just another concept, whenever body moving with uniform speed, then the motion of the body is said to be uniform motion. Just see the definition concept of both. When the body covers equal distances in equal interval of time, then the motion of the body is said to be uniform motion. Clear? It means two concepts. In first definition, equal distances in equal interval of time. Whenever body covers equal distances in equal interval of time, then the motion is said to be uniform motion. Another concept, when the body moving with uniform speed, then the motion of the body is said to be uniform motion. Clear? Definition concept. If you just write this definition, then your concept is clear. If otherwise you are writing this definition, then your concept also clear. Because in both the definition concept, that is equal distance in equal interval of time, is given. Uniform speed means what? Whenever body moving with uniform speed, it means covers equal distances in equal interval of time. And when you just using the concept equal distances in equal interval of time, then the body motion is said to be uniform motion, or in the terms of uniform speed you can also define uniform motion. Example, suppose a car moving from A to B up to 10 kilometer in 5 minutes. 10 kilometer in 5 minutes. Then again covers distances from B to C, that is 10 kilometer in 5 minutes. Then the speed of the car is said to be what? Uniform speed, and the motion, that is motion traveled by the distances from A to B and B to C, then the motion of the car is said to be what? Uniform motion. So concept of uniform, that is very easy. Equal distances in equal interval of time, whenever covers by the body or any object or car, then the motion is said to be what? Uniform motion. And then after uniform, non-uniform. Non-uniform motion. Simple definition: when the body does not cover equal distance in equal interval of time. I will say that when body covers equal distances in unequal interval of time, then the motion of the body is said to be non-uniform motion, or in other words, when the body moving with non-uniform speed, then the motion is said to be non-uniform motion. Just see, when the body covers unequal distances out of given two, that is yet distances and time, anyone you can take unequal. So I am taking what? Unequal distances. Unequal distances in equal interval of time. Equal interval of time. Then the motion of the body is said to be non-uniform motion. An example, same way you can explain. If the body covers A to B distances, that is 15 kilometer in 1 hour, and from B to C, that is 5 kilometer in 1 hour, then here time interval is same. From A to B time taken 1 hour, and from B to C time taken also 1 hour, but distances here 15 kilometer and 5 kilometer, that is unequal. It means the motion of the body is non-uniform motion. Just note down. After this we will discuss about the graph concept. Just note down. Just after the definition of uniform and non-uniform motion, the most important concept of this chapter, that is distance time graph and speed time graph. Just see what is the concept of distance time graph and speed time graph. Distance time graph and speed time graph. At the place of speed, if somewhere given velocity, there is no matter. Whenever speed time graph, then the area under speed time graph gives what? Distance and area under velocity time graph gives displacement. How gives distance and displacement will be clear, very easy. Just see distance time graph. If the y-axis representing distance and x-axis representing time, this is the time axis and this is distance, or you say the displacement no matter, distance. Whenever distance and time, speed concept is asking, then you just draw the graph distance and time. This is the origin point, and this one, whenever straight line of distance time graph, then it is representing what? Speed. And in which case representing speed? Whenever taking slope. Here this is y-axis representing what? Distance, and x-axis representing time. And slope of distance time graph. This is angle theta is equal to what? Slope. Whenever straight line, when the graph is straight line, then the motion of the body is said to be what? Uniform motion, and the speed of the body is uniform speed. Uniform motion. And slope of distance time graph representing speed. Clear? Very easy. Slope of distance time graph representing speed. And when the graph is straight line, then the motion is uniform motion. It means when the graph is not a straight line, then the motion is non-uniform. Just see, this is y-axis, and here distance, and here x-axis, that is time. Origin. If graph either in this way, another graph I just representing here time axis, and here distance axis. This is y-axis and this is x-axis. If graph in this way, convex in upward or convex in downward, then in both the case motion of the body is non-uniform. I think the concept about uniform and non-uniform is clear. Very simple concept. Just always remember, when we just take here distance then the concept of speed, and when we take a displacement, then the concept will be velocity, because distance means scalar, so speed scalar quantity. When we take displacement, that is vector, then we obtain what? Velocity. And in which case the motion is uniform whenever the straight line obtained, graph of moving body whenever obtaining what? Straight line, then the motion is uniform motion. And whenever curved line, either convex upwards or convex downward, no matter, whenever curved line obtained, then the motion of the body is non-uniform motion. Then after this, distance time graph concept is clear. And when we take the area under distance time graph, not distance time, speed time graph, then how representing speed time graph area distance, just see after this. Very easy concept. Suppose this is time axis and this one is speed axis, that is y axis representing speed and x axis representing time. Then area under speed time graph, so this is graph from A to B or O to A, no matter. This is graph speed time representing by OA. Then area under speed time graph and bounded by time axis. Bounded by time axis. This is the graph. And how area under speed time graph representing distance. Just see, very easy concept. Here this is a shape of triangle, and triangle, which type of triangle? Right angle triangle. Right angle triangle. And when we calculate area, then area triangle or area under speed time graph. Speed time graph is equal to what? Area here, triangle area, right angle, 1/2 base multiply height. 1/2 into base means what? Time. Suppose the time here t and speed here v. So t into v, and we are knowing that what? Speed is equal to distance upon time. So 1/2 into time into distance years upon t. So t cancel out. So is equal to 1/2 into years. That is representing what? Distance. Area under speed time graph, when we just calculate, then representing distance. And when we take area under velocity time graph, area under velocity time graph, then this one will be what? Displacement. And one more concept that is very important, just note down. The concept of distance, whenever area under speed time graph calculated, speed means what? Scalar quantity. That's why here scalar distance obtained. When we take velocity at the place of speed, then we obtain what? Displacement. Next one important concept, slope of velocity time graph. Slope of velocity time graph representing acceleration. Suppose here time axis and here velocity axis, that is y axis representing velocity axis and x axis representing time axis. Then the slope is on angle is equal to what? Slope O to A. Slope theta is equal to slope is equal to, always remember, whenever slope given, then slope means what? Tan theta, and tan theta is equal to perpendicular upon base. Perpendicular upon, suppose the velocity here from A to B, that is V, and time from O to B, that is T. If then slope is equal to theta is equal to what? Acceleration, and acceleration concept in this triangle, right angle triangle, we have to calculate what? Tan theta. For class 9 this is different word, but in class 10th you will learn about all sin, cos, tan, cos, etc. cot, no matter, but always remember the concept of theta means what? That is slope, and slope means tan theta is equal to what? Perpendicular upon base. So acceleration is equal to V upon T. Here initial velocity 0, and if initial velocity u and final velocity v, then change in velocity will be what? V minus u upon t. So no matter, you will just learn three concepts. Listen again. Slope of distance time graph representing speed, or you say that displacement time graph representing velocity. Why displacement time representing velocity? Because displacement is a vector, that's why velocity concept obtained. Whenever you just take distance time graph slope, then giving what? Speed concept. And then after this, area under speed time graph, area under speed time graph representing what? Distance. When we take velocity time graph, then representing what? Displacement. And slope of velocity time graph, acceleration. Or you take slope of speed time graph, then also representing what? Acceleration. Then all these three concepts that are very important for deriving the equations of motion by graphical method. By graphical method. In easy way, only one graph is sufficient to solve out the numerical concept. Anyone given on base of graph, we will solve just few numericals. You just concentrate about the concept of numerical, then everything will be clear. Just see. Suppose a distance time graph is given, and you have to calculate what? Speed. You have to calculate speed. You see, distance in meter. Here 2 meter, 4 meter, 6 meter, 8 meter, and time 1 second, 2 second, 3 second, 4 second, 5 second. And we have to calculate what? Speed. We have to calculate speed. Then speed from A to B. Here this is point A, and this is point B. From A to B, what is the concept of speed? What is the concept of speed here? Along time axis, The time is 1 second, 2 second, 3 second, 4 second and 5 second. And here distance 2 meter, 4 meter, 6 meter, 8 meter. We have to calculate what? Speed from A to B. Speed means slope of distance time graph. When we just move from O to A, then this is the graph, and when we from move A to B, then this portion is the graph. And calculate what? Speed of moving body from A to B. Here this is a straight line, it means uniform speed, or you say that uniform motion, but we have to calculate what? Speed from A to B. So at point A, distance is equal to 4 meter and time is equal to 2 seconds. Time is equal to 2 seconds. Then speed is equal to distance upon time. Distance upon time. Distance from O to A at point A, that is 4 meter. This one is 4 meter, and time from O to, suppose this one point C, O to C, that is 2 seconds. That is 2 seconds. And then O to C here 2 seconds, and distance here 4 meter. So 4 upon 2 meter per second, that is equal to what? 2 meter per second. If the speed at point B is same, that is 2 meter per second, it means what? It is clear that the graph of this motion is uniform concept. Speed at point B, at point, this is the numerical concept. Speed at point B is equal to distance here, that is this point from B to D, that is 8 meter. 8 meter. Distance is equal to 8 meter and time is equal to 4 seconds. Just from O to D, that is here 1, 2, 3 and 4. From O to B, that is 4 seconds, and here from D to B, that is 8 meter. 8 meter. Then speed is equal to distance upon time. Distance upon time is equal to what? 8 upon 4 is equal to 2 meter per second. Here, if the data is not clear, then I am speaking what the value is given. Along y-axis 2 meter, 4 meter, 6 meter, 8 meter. And along x-axis, this is y-axis and this is x-axis. Along x-axis 1 second, 2 second, 3 second, 4 second. At point A, when we just draw perpendicular, then meet at C, that is 2 second. And when we at from point B, when we draw perpendicular on time axis, then meet at D, it means 4 second. So timing 4 second, distance what? 8 meter. So 8 upon 4 means what? 2 meter per second. It means speed at point A and speed at point B both are same. That is 2 meter per second. It is clear that the motion is uniform. It is clear that from calculation speed of a moving body is uniform and the graph is uniform also. Graph is also uniform motion. Everything is clear, very easy concept, just note down. After this we will solve another numerical. Just after the calculation of speed from distance time graph, the next one numerical, that is based on speed time graph. Speed time graph. Suppose you have to calculate what? Calculate acceleration from O to A and from B to C. Suppose if asking about acceleration from A to B, then there will be no acceleration, because from A to B, here speed that is same, that is 6 meter per second. Here speed concept from A to B, that is 6 meter per second. It means there is no changing in speed from A to B. Whenever there is no changing in speed from A to B, means what? That is moving with uniform acceleration. Acceleration is same from A to B, but we have to calculate what? Speed time graph concept and calculating acceleration from O to A and from B to C, where the acceleration is changing. Acceleration from A to B, acceleration from A to B is 0. Why 0? Because speed is same. Whenever speed is same, then u and v both become 0. Whenever subtract, that is v minus u is equal to what? 0. Whenever v is equal to u, then v minus u is equal to 0. It means there is no chance of acceleration from A to B, but acceleration from O to A, from O to A, acceleration is equal to, here at point O, the speed is 0. Here nothing given, means what? That is 0, and here 2, 4, 6, 8, 10 in meter per second. Speed given in meter per second and time here given in seconds. So from O to A, at point O, that is 0, at point A, that is 6. So 6 minus 0, and time here, we will draw perpendicular from A to time axis. Suppose this one point is D, then this one is 6 meter per second, and time here that is 2 second. Time 2 second, and this one is speed 6. So 6 minus 0, at point is 6 and point is 0. The time here 2, and at this point time is 2, and at this point that is 0. So 2 minus 0, no matter, only 2. So 6 upon 2, that is equal to 3 meter per second square. This is the acceleration. This is the acceleration of a moving body. 6 upon 2 equal to what? 3 meter per second square. Clear? And then from B to C, acceleration from B to C, acceleration is equal to at point C, the acceleration concept will obtain whenever the speed concept here clear. Speed at point C, that is 0, and at point B, that is 6. 0 minus 6 upon time, that is 6 minus 0 means what? 6. Not 6 minus 0. from B to C, this is 6 and at this one at point 4. 6 minus 4. So minus 6 upon 2, that is equal to what? Minus 3 meter per second square. It means here negative value means what? The concept of negative value always representing retardation. It means at point B, when this body reached at point B, then applying what? Brake. And when applying brake, then the speed decreases and becomes what? 0 at point C. It means this is the negative acceleration graph. This is the graph of retardation graph. And this one for acceleration graph. And here zero acceleration, because there is no change in velocity or speed. Whenever there is no change in speed, that means what? Acceleration 0. Suppose we have to calculate what? Displacement. Here speed given means distance. Whenever velocity given, then you can calculate what? Displacement, but speed is given. Suppose you have to calculate what? Distance. Then area under speed time graph. Area under, just note down this one very simple concept. When even the concept is slope of speed time graph representing acceleration. And suppose you have to calculate what? Distance. Then during whole motion from O to A and further B and then from B to C, suppose you have to calculate what? Distance. Then how representing distance? Speed time graph under area. This one area. If we just calculate the area under this speed time graph, then distance from O to A and A to B, then up to C. It means body starting from O and reached at A and then further B and at last C. During whole journey, how much distance covered? Then S is equal to area under speed time graph. That is equal to, this is a shape of trapezium, and trapezium area sum of parallel side into height upon 2. From A to B, the time is 2 to 4, that is 2. This one representing what? 2, and O to C means representing 6. So upper parallel and lower parallel side clear, that is 2 and 6. So sum of parallel side 2 plus 6, and height, it means distance between both. This is 6 and this is 0. So 0 to 6, that is 6. So 2 3 is 6. So that is equal to 8 into 3, that is equal to 24 meter. See, answer of distance. And if we just calculate in part wise, that is from O to A, what is the distance? Then the answer will be same. So see, in part wise calculation, from O to A, distance, that is 1 upon 2 into 6. S is equal to 1 upon 2 into 6 into 2, then is equal to 6 meter. And A to B, distance S is equal to, this is a shape of rectangle. So this one 2 and this one 6. So 2 into 6, rectangle area, that is length into breadth. So 2 into 6 is equal to 12 meter. And from B to C, again triangle, B to C, distance S is equal to half base multiply height. So 1 upon 2 into base here, 2 into height 6. So 2 to cancel is equal to 6 meter. It means when we add 6, 12 and 6, that is equal to what? 24. Either calculating by direct formula of area of trapezium, then the answer is same when we just calculate in part wise, that is area of triangle, area of rectangle and area of triangle. So in any one method you can use to find out the distance value. If further any confusion, any numericals either in your NCERT book or in any side book, then you can ask and just revise each and everything that is given in your book related to either distance time graph or speed time graph or velocity time graph or displacement time graph, and the numerical based on either uniform motion or non-uniform motion, how the concept of graph is given. So each and everything that is very important for your examination point of view, you will revise the whole thing completely. If any doubt, then you can ask. Thank you so much. Have a nice day.